All right, let's dive right in. Today, we're going to tackle time series data, but we're going to do it a little differently. We're going to treat it like an investigation, and we get to be the detectives. Our job is to find the hidden patterns and the stories buried inside the numbers using a process called exploratory data analysis, or EDA. So, let's start the case.
So, picture this. Someone walks up to your desk and drops off this massive data set. It's years and years of daily sales data for thousands of different products. And the goal is simple. Just tell us what's going to happen next month. It's just this huge, tangled mess of numbers, right? It can feel totally overwhelming. Where do you even begin with something like that?
Well, here's the secret. You don't look forward. Not yet, anyway. The very first step to predicting the future is becoming an expert on the past. You got to put on that detective hat, pull out the magnifying glass, and really dig into that historical data. It doesn't matter how chaotic it looks, because I promise you, the clues to what's coming next, they're all buried in there. Our job is to find.
So here's our game plan. First, we'll define the mission in the case of the squiggly line. Then we'll get to know the data, our key witnesses, if you will. After that, we'll start searching for some initial clues, and then get into the art of asking the right questions. We'll even learn how to see through all the noise to find the real patterns. And finally, we'll put all the pieces together to tell the story.
You know, every good investigation starts with a really clear objective. Before we even dream of writing a single line of code or making a single chart, we have to know exactly what problem we're trying to solve. Getting this right is the difference between finding real, valuable insights and, well, just making a bunch of pretty but useless graphs. So here it is. This is our mission, and it's pulled from a real-world forecasting competition. We've got historical sales data for a ton of different Walmart products across 3 states, California, Texas, and Wisconsin. Our job is to use all this past data, which covers more than 1,900 days, to predict what sales will look like for the next 28 days. The stakes are high, and believe me, the data is complex. Okay, mission defined. Now it's time for the first real step in any data investigation. We need to open up the case files and get to know the evidence. Who are the key players here? What kind of information do we actually have to work with? Let's meet our data sets. So our evidence comes in 3 main files. You can think of these as our primary sources. We've got a calendar file, which gives us all the context around time. We have the sales training file, that's really the heart of our whole case. And we have a sell prices file. Each one holds a totally different piece of the puzzle. First up is calendar.csv. Now, this isn't just a list of dates. It's our investigation's timeline. It tells us the day of the week, the month, the year, but what's really crucial is that it flags special events. Things like the Super Bowl, Christmas, other holidays. These are huge potential clues, right? These are the kinds of events that could be driving massive swings in sales. And now, for the main event, salestrainvalidation.csv. This file is, well, it's massive. It has the daily sales numbers for thousands of individual products, stretching across almost 2,000 days. Every single row is a different product, and every column is a different day's sales. This is where all the secrets, all the patterns we're looking for are hiding. Okay, so we've got our mission, and we've met the data. Now the real detective work can finally start. We're going to begin by what you might call canvassing the scene. We're looking for the big, obvious, high-level patterns. We're not digging for subtle clues just yet. We're just trying to get the lay of the land. And a quick look at our calendar data gives us our first piece of really good news. When we count up the entries for each day of the week, they're all perfectly even. That tells us we have a complete data set, no missing days, which is a huge relief. The monthly counts are also pretty consistent. So bottom line, we're working with a solid, reliable timeline. Good start. Aha, here we go, our first major clue. This chart shows the total items sold, broken down by state. And wow, it's not even close. California is the clear leader, selling way more stuff than Texas or Wisconsin. This tells us right away that we can't treat all the states the same. Location matters. A lot. It kind of makes you wonder, right? Is that just because of population, or are people in California buying totally different things? And we see another huge pattern when we look at sales by product category. One category, foods, absolutely dwarfs the others. I mean, it outsells household and hobbies combined, easily. This is a massive insight. It means the overall sales trend is probably being driven by groceries. So any model we build has to get that part right. So we found some big clues, right? California sells the most, and food is the biggest category.
But any good detective knows the real story is always in the details. So it's time to move from these broad observations to a more specific interrogation. We need to start asking sharper, more focused questions of our data.
And this feels like the next logical question, doesn't it? We know the big trends, but what does the day-to-day sales life of just one single product actually look like? If we zoom all the way in from that 30,000-foot view down to just one item on one shelf, what are we going to see? Let's pick one and find out.
And here's our answer. This is the daily sales for one food item over that entire period. It's a mess. It's just a jagged, chaotic, squiggly line. It shoots up, it crashes down, there are huge spikes, and then sudden drops to zero. Trying to find a clear pattern in this is like trying to hear a whisper in the middle of a hurricane. This is the reality of raw data.
And hey, it's not just us. The author of the analysis we're looking at says it perfectly. The plots are very random, and it is difficult to find out a pattern. This totally validates what we're seeing. The signal we're looking for, that true underlying sales trend, it's buried under a mountain of what data scientists call noise.
So, what do? How does a detective see through all this chaos to find the truth? Well, we need a more advanced tool in our kit. It's time to learn how to filter out all that random noise so we can reveal the real story hidden underneath.
The technique is called denoising. And it's pretty much exactly what it sounds like. It's a whole set of methods designed to separate the meaningful signal from all those random, meaningless ups and downs. By applying a denoising filter, we can smooth out that jagged line and finally see the underlying shape of the data more clearly. Now, there are a couple of ways to do this. There are some really sophisticated methods like wavelet denoising, which use some pretty complex math. But there's also a much simpler, more intuitive way called a moving average. Just imagine taking the sales from the last, say, 30 days and finding the average. Then you slide forward one day and do it again and again and again. When you plot those averages, you smooth out all the daily bumps and you start to see a much clearer trend. And when we apply a technique like that, moving average, to our chaotic plot, something amazing happens. All that noise just fades into the background and a much clearer, smoother curve starts to emerge. And all of a sudden, we can see things we totally missed before, like potential seasonal patterns, where sales predictably go up and down at certain times of the year. The hidden trend is finally revealed. Okay, we've defined our mission, we've looked at the evidence, found some clues, asked deeper questions, and even used some advanced techniques to see through the noise. Now it's time to step back, look at everything we've found, and piece together the final story that our data is trying to tell us. So, what did our investigation actually uncover? First, that the big picture can be really misleading. The real action is hidden in the data for each individual product. Second, sales are wildly different depending on the state and the category. And third, the most important patterns are often completely invisible until you filter out all the noise. And this all leads to one absolutely crucial takeaway. This detective work, this EDA, is the essential first step. You just can't build a reliable predictive model without it. You know, at the end of the day, every collection of data is telling a story. It doesn't matter if it's sales figures or stock prices or website traffic. There are characters, there are plot twists, and hidden motives. And the tools of exploratory data analysis, they're what let you become the detective who uncovers that story. So the only real question left is, when you get your next case file, what story are you going to discover?